All right, welcome back. This is part three on our series on Trendline. So we're gonna dive further deep into this. We've got pre-solar data, the original data. We've got a trend line representing the original data. We've got the equation for the trend line also, and we've got two data points on the post-solar data. Now notice in this pre-solar data, the trend line and the equation that we have, the equation has x variable and it has coefficients, predicts y. The y is something that we see. We want to write this manually down. The reason why we want to write this manually down is, for one, prove that this equation actually does result in this dotted trend line. And also, if we can write this manually down, we could move this around. Notice there's a trend right here in the two data points. These two data points are slightly shifted down, meaning you have a smaller electricity bill, right? And that's probably going to be the case for the rest of the months also, because the seasons are going to remain the same for the rest of the months. So you should expect a similar pattern. So what that really means is shifting this trend line down. So if we could manually create this trend line, maybe we could shift it down also and have those as predictions for the post solar months. So let's manually set this down. Now this equation has these coefficients. I'm going to write these coefficients down. I'm going to call them x cube coefficient, x square coefficient, and then x coefficient. And then there's also an intercept, which is where the curve cuts the y-axis. We also, remember, have x cube, x square, the variable itself, and then x. All right, so this is something that we also have. Let's put these values in. So x cubed coefficient is minus 356.81. X square coefficient is 9326.6 minus 63027, and the intercept is 151374. X cubed is the value that the variable takes. For the first month, it's 1. For the second, it's 2. This is by default with Excel. If I could right click, select data, go to these, notice these are the values that Excel takes. The relationship is between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and these amounts. That's what the trend line is relating x and y as. Okay, so if my x, I should write this as x, keep this as x squared, and then this as x cubed. Yeah, that would be a nicer way to do it. All right, so x is 1, 2, 3, and I'll let Excel identify this trend until 12. This is simply x times x, and extend this for x squared. This is simply x times x times x, x cubed, and it's going to be this, right? The coefficients are the same, all right? We don't see a change in coefficients. They're constants, they're fixed. Only the x variables change for different months, right? And we're going to compute a y for this. So what would y be for the first month? All right, so it's going to be x, this coefficient. I'm going to put brackets when I multiply them just to be safe. X cube coefficient times x cube plus x square coefficient times x square plus x coefficient times x plus the intercept. Hit enter and I get a number 97,000, which is, by the way, right here. It's close to 100,000, 97,000. That's my first data point. Turns out to be correct. I can always drag this all the way down to get the remaining data points, but I seem to have a problem, and I'll click a random place and go to the formula bar just to verify. So you see these, when you extended this formula, it also extended for the coefficients, but the coefficients are constants. They're supposed to remain the same. So this was supposed to remain the same for all of them, right? So one of the ways you could fix that is by inserting dollar signs on the coefficients in your calculations, right? So I'm going to put dollar signs in all my coefficients only. The variables don't need to be fixed. Variables will go from 1 to 12, but the coefficients remain the same in all the multiplications. And also the intercept is also supposed to be fixed. Now when I extend this, you'll notice that I get these numbers and I get the correct coefficients. This is my y, the manually created trend line, but it's a good idea to also visualize this on the same graph, and it should appear on this dotted line because we just use the same equation to construct this. But just as a proof, I'm just going to go ahead, select data, add this y manual, and choose this data point. Hit enter. Okay. And what do I see? Yeah, this is pretty much the same, just goes slightly away. Wonder why that happens. For the last few data points. It seems to be yeah, it seems to be correct. But I do see the trend line slightly deviating away. And one of the reasons this could possibly happen is that the coefficients are only a couple of decimal places or no decimal places. And technically, if you look at the trend line equation, this is supposed to have many decimal places in them, and probably it's down to that specific accuracy. So we're gonna go ahead with this, but we will I'm just making sure if my coefficients are correctly multiplied. Yeah, they are. Okay. But we have our trend line, and what we're gonna do now is have this trend line in gray. This is the manual trend line. Change our intercept ever so slightly to notice that it changes how our trend line varies, right? We could shift our trend line. I'm going to try 131 and bring it further down slightly here. So it's the same trend line, kind of shifted downwards just a little bit. Might even try 130. Yeah, so it's maybe 129. So I get the same trend. I don't want to make it less than 0. That would mean the utility is paying us, which is not the case. The grid is paying us for excess electricity production, which is not happening. So we're not going to go below 0, but this trend is now replicated for our prediction case, right? For the post-solar case. So we're going to go ahead with this, and might as well reduce or delete the first data point because we have an actual value for it. And the second, if I remove the second data point also, I'll lose this connectivity. So I'll keep the second, Control Z to bring undo, and I'll keep the second data point. All right, we're gonna wrap this part of the video, and I'll see you in the next one with more analysis and formatting. All right, see you in the next one.